Standardization methods. There's direct standardization and indirect standardization. So direct and indirect doesn't really tell you what's going on. I prefer internally standardized and externally standardized. It helps me keep it straight in my mind a little bit easier. So in direct standardization, you're taking stratum-specific rates of the study population, and they're applied to the confounder distribution of a standard population. So what you're doing here is you're applying the same set of weights to the stratum-specific rates to make them comparable. And this is externally standardized. So here you have your different stratum, say stratum 1, stratum 2, and stratum 3 in population A. So rate 1, rate 2, rate 3. And then you have population B. Same thing, your rates in your 3 different strata. And now you have a standard population. So we have the 3. So now what you're going to do is you're going to take this rate and you're going to multiply it by the equivalent distribution of that confounder in your standard population. So say this is H. And you're going to do it for each of your study populations. So now what you have is your rates from your study population and your weights from your standard population. And because all of these populations that you're looking at, your study populations, have now been weighted using the same distribution in your standard, they are now comparable. It's called externally standardized because you're using an external population structure in your standard population to actually standardize your rates. In indirect standardization, your stratum-specific rates from the standard population, so this is the mirror image of direct standardization, are applied to the age distribution of the study population. So this is called internally standardized. So differently here, you have your rates in your standard, okay, so these are your 3 stratum in your standard population, rate 1, rate 2, rate 3. And then you have your study population. So say Ecuador, Sweden, UAE, and Canada. So if you're looking at all 3 of those countries, you're now going to multiply the standard population rates in each strata by the weights in each country. So this is the distribution of age in each country. So why this is internally standardized is you're using the weights from your study populations and your rates are coming from your standard. So I really like this chart down here. I find it's a really good way to kind of wrap your head around what's going on. It tells you for each type of standardization what your study population is giving you and what your standard population is giving you. So your study population is what your observed is, so your actual study, and your standardization is what you're using to standardize. Okay? So we'll go through these in more detail. So for direct standardization, we just said that it is externally standardized. So stratum-specific rates of study populations are applied to the age distribution of the standard population. It applies the same set of weights to the stratum-specific rates to make them comparable. We compare different populations by working out how many events there would be if each population kept its own observed stratum-specific rates, but the structure of each population was the same. So here are 2 formulas if you are a person who prefers to see formula. So this is for rates, and this is for risks. Okay, so all this tells you is the sum, so you're just adding up for each stratum. Here is the standard distribution of population time at risk for rates multiplied by your stratum-specific rates. So this is your standard, and this is your study population or observed. Here's for risk. So same thing, this is a sum, so you're just summing up each of the strata. This is your standard population of the proportion of animals for risk in each level or stratum. And here is your risk in your study population. So this is your observed. Okay, so we're going to go through these in more detail. So your first step for direct standardization is to calculate stratum-specific rates for each group in the population. So remember here we've stratified on age because we have our 3 age categories. This gives you your crude by just doing the whole population. Okay, remember you can't add down. So to get your stratum-specific rate, here we have assumed it's for 1 year, so you've already kind of dealt with that unit here. So we have the number of events, so deaths, divided by that denominator. Should give you 2.2 deaths per 1,000 person years. So pause it now, go through all of these and calculate them yourselves, and I will give you the answers. Hint, you've already actually done this in a previous slide. If you get stuck, okay, so here we go. We have our stratum-specific rates for each country and our crude rates. So remember, you can't add these up to get your crude rate. That's super important. This is just... Okay. Now, second step is to choose a standard population. So these are just artificial populations with different confounder or attribute structures that are used in standardization as a uniform basis for the calculation of comparable measures for respective reference populations. So there's a lot of different ones that you can choose from. You can also make your own. So how do you pick a standard population? So standardized measures describe a hypothetical state of affairs, which is a function of the standard population chosen. So your crude rate is a true value, that's what you've seen in the population. A standardized rate is a theoretical value. And it is important to know that you will get different standardized rates based on the standard chosen. So if you pick one standard, it could tell you population A has a higher rate of disease, but based on a second standard, you could actually find out that population B has a higher rate of disease. So it's really important to consider your standard population choice wisely. When several different populations are being compared, a pooled standard minimizes the variance of the adjusted rates. So basically what you do here is you take the attribute or the confounder distribution in all of the populations and you average them. So this will minimize the variance. You can also use predefined standard populations. So these are things like what I showed you in the previous slide, or the African standard, European standard, or the world standard. These all have very different distributions, so you should look at them before picking them. And examining trends, an appropriate standard is one that reflects the average structure of the population over the time period, and the standard should be similar to the population of interest. So here's just an example. So this is our standard for our particular example. 56% of this population is within 0 to 29, 33% is in the 30 to 59 category, and 11% is in the 60 plus. And this is how it compares to our two study populations. So it's probably close enough for a comparison of these two populations, but averaging them may be a better standard. So now for your step 3, you need to calculate the expected rates. So this is all you're doing is you're applying the stratum-specific rates. So remember, this is from your study to your standard population. So in that calculation, it's IJT multiplied by TJ. So this is just the kind of table you had before. This is what we previously calculated was your stratum-specific observed rate. So it's just number of deaths divided by population, and that's how you got this value. So here's your standard population distribution. How I got the proportion is it's literally just the number of individuals in this category or this stratum divided by the total. Here it's lucky because it's just 100,000, so I just had to add a 0.0. So here we have 56% in this category, 33 in this category, and 11. So usually in an exam you'll be just given this here, but if you're given the numbers instead, this is how you calculate them. Okay, so this gives you the standard population distribution or proportion. So this is your standard and this is your observed. Okay, so because we are doing a direct standardization, so we're externally standardizing, we're going to take our observed rates from our particular study population, which is this here, and we're going to weight it or multiply it by our standard population, so our external population. So how we're going to do that, so for say category 0 to 29, it's just going to be 2.2. So this is the stratum, our observed rate, multiplied by the proportion of 0 to 29-year-olds in our standard population. Okay, and that's going to give you 1.23. Now we're going to do it for the next one. We have our stratum-specific observed rate from our population. So IJ, which is 3.7. We're going to multiply it, so we're weighting it, by the proportion of 0 to 59-year-olds in our standard population, 0.33. It's going to give us 1.22. And then the last one is the 60 plus category. So we're going to take the observed rate in that category from our standard population, which is 48.7. And we're going to multiply it by the proportion of 60 plus year olds in our standard population, and that external population, which is 0.11. Leads us to 5.36. Okay, so now what we have to do to get the age-adjusted mortality rate is you just have to add all of these up. Okay, because it's a sum. Remember, it's just the sum of IJ times TJ for each strata. So we have strata 1, strata 2, strata 3. So the sum is just adding all of those up. Okay, so that gives us a total age-adjusted, directly adjusted mortality rate of 7.81 for Ecuador. Okay, so here, because we have used a proportion, we've skipped a couple steps. If you use other references, you're going to have to do some dividing at the end, but this way is probably the easiest. Okay, now we're going to go to Sweden. Well, it's exactly the same thing as we had just done for Ecuador. So we have our stratum-specific observed rate from our population, and we have our standard population distribution from our standard. Okay, we're using the same standard to weight the Sweden population as we did the Ecuadorian one, and that's why they're now comparable. So to compare the first one, just remember it's IJ, so your stratum-specific observed rate from your study population, multiplied by the proportion of that stratum in your standard population, equals 0.25. Okay, so now do the rest by yourself, these two, to practice. I'll give you the answer. read my terrible tablet writing. Okay, so these are the two answers. And then to get your age-adjusted mortality rate, remember, it's just the sum. So you're just going to add up these values. Should be 0.25. Which gives you an age-adjusted mortality rate of 5.70. Okay, so here's our crude from before, which was 10.5, and now that we've adjusted for age, it's 5.7, so it's half of the size. Okay, the age-adjusted mortality rate of Ecuador is 7.81. Well, that didn't work. Okay. So now you can see after we've adjusted for age, Sweden actually has a much lower death rate compared to Ecuador when we're just looking at those age-adjusted mortality rates. So an optional step after that is to calculate standardized rate ratio or standardized rate difference if you actually want to know what the real difference is in the rate between those two groups. So your standardized rate ratio is just the directly standardized rate in population 1 divided by the directly standardized population rate for your second population. So this one, it would just be the rate in Ecuador divided by the standardized rate in Sweden equals 1.37. So if you got a ratio of 1, that means that they're the same. Okay? If this is larger, it means that population 1 has a higher rate than population 2 by about 37%. So let's say greater than 1 equals higher rate, equals 1 equals the same. And if it's less than 1, that means that there is a lower rate. Okay, so that's all that SRR is telling you. You also don't need the scaling factor here because it's just a ratio. For the standardized rate difference, all you're going to take is the standardized rate in population 1, so that's 7.8 for Ecuador, subtracted by the directly standardized rate in population 2, which is 5.71 for Sweden, which equals 2.1. Remember, because you're subtracting, you need to have that scaling factor there, okay? So it's 2.1 deaths per 100,000 or 1,000 person years. So these are your two differences between your populations if you're interested in. Generally, on an exam, they'll just ask you for which one's higher, but if you wanted to give a standardized rate ratio or a standardized rate difference, this is what you can produce.